All right, you guys find your notes. We're going to talk about the Earth as a magnet and electromagnets today. So that
What about the magnet?
we're going to talk about that too. Oh, yeah. Thank you. I'm glad you said that.
No, not you.
That won't take us long.
I don't got.
All right. We're going to take a quiz.
Really?
What's tomorrow? Thursday?
Yeah.
Friday.
Why?
Why? Because I can't.
Did you say we have a test Friday?
I don't know. No, tell us what's for lunch back there. So you're standing there. What's for lunch?
I said I wasn't gonna be here.
It's what?
Turkey and cheese.
Turkey and cheese.
Anything
Doesn't
else?
that just make y'all want to rush to lunch at 1:40?
No.
What's one?
Yeah.
Turkey and cheese.
We should do the test.
And what?
Cheese
Cheese and steak.
Oh.
Oh, I'll eat a pizza. Yeah, turkey.
Nope. Quiz is on Friday. Test is on Monday.
Well, you should give me the quiz tomorrow, since I'm not gonna be here Friday.
I can.
Yeah, just do that.
Do it during lunch.
Alright.
Only 10 multiple choice questions. It won't take you long.
Yeah.
All right. Answer these real quick. We're going to go over them in about 5 minutes. I'm not giving you long. Because it won't take us long to do these. Yep. I'm sure it won't take us long to do these. It's pretty quick. I'm going to go grab my lodestone. Actually, I think I have magnetite.
Good luck. As well.
Yep, we are.
All right, thank you.
Tyler, did you just join an existing lab group and copy down what they had on their lab?
No.
So you went back and restarted and did the entire lab from beginning to end?
I had the stuff out. I was just hanging out with them because I knew some stuff.
Somehow I doubt that. You're not the most trusting person on the planet.
Who, me? I'm pretty trusting.
No, I'm not.
So, you don't trust me?
I don't trust anybody.
Why? Why?
That was it?
What's that?
What?
I'm getting some. Whatever.
You're a teenager.
Oh my God. I wanna keep my name.
Do you trust your family?
Where?
Part of them, not all of them.
Where?
I feel that.
Where?
You are teenagers.
I'll go by. I don't know who he was before. I will remember that.
All right, you got my questions answered? Because when I call on y'all, won't you tell me an answer?
Me?
Any of them.
I have some answers.
What?
Did you put something else?
Possibly, depends on what it is.
So, wait.
No, I don't. I can't do labels.
Thank you.
You're welcome. You done? Trevor? Are we all done?
Iron film.
What?
Would it be mostly in the middle?
No.
Which one?
Holes. Who's still working on the paper? You got left, Jose. Don't tell me the whole page. I'm gonna come over there and hit you in the head. Because the way you just laughed at me, it's like I ain't started this as well.
Can't wait to go to the buffet in the summer.
Can't wait to go where?
The buffet in the summer.
Okay. I'm gonna worry about you that you're salivating about a meal that's months away.
I love food so much. Honestly,
Where's your drawing?
Chinese buffet. But it has like Japanese food too. Golden Corral is not cutting for me. They always have like less of something. You gotta ask them to cut your food. I can't even have if I didn't have a metabolism, I would be the fattest person. I would like 240.
Yes, please.
Right.
Stop, Jose.
All right, let's take a look at what you came up with. We find the paper. So if we look at the top one, where's my blue chair? Nigel, where's the blue chair? Bring it back. Should have known you had it.
Oh, there's a black chair too.
Yes, I know, but it's on the other side.
It is like very loud and I walk right up there. How do you not?
I don't pay attention. I keep telling you guys that I can sit in the cafeteria and not notice y'all are there. So I don't really notice the chair.
This is a lot of work.
You could just stand behind it and roll it up.
But then where's the fun of it?
Yeah. All right, so question one. What can you tell me about the lines when you have them doing this number? Are they repelling or attracting? They're repelling. So if you have an S, what does the next one have to be? Has to be an S. All right, when they have the lines going towards each other in that group, what do you know they're doing? So it has to be an S with a what? Has to be an S with an N. All right, what generalizations can you make about the reaction between like poles? Likes repel. They're the same. Remember, like and same repel. What generalizations can you make about unlike poles? Say it right. Draw the lines that show what would happen around your bar magnet. So around the bar magnet, would it look like the SS up top or the SN? The SNs. They should look like those lines for SN at the top. All right. Where would most of the iron filings be located?
Around the edges.
What do we call the edges? Holes. Okay. All right. Where would most of the iron filings be spread out? In the middle. All right. What can you infer about the strength of the magnetic field based on the position of the iron filings? It's stronger where? At the poles. Instead of saying ends, call them the poles. So it's stronger at the poles. and it's weaker where? It's weaker in the middle, stronger at the poles. Alright? Based on what I've graded on your labs, y'all got hammered on number 8.
What's number 8?
What types of materials make good magnets? Ferromagnetic. So on number 4 on page 1 of your lab sheet, it said what kind of materials were magnetic? Y'all wrote iron and nail or metals. That is the wrong answer every day of the week. What types of materials make good magnets? That is what you should have written on your lab sheet, just like number 8 on your worksheet. I have yet to read a paper that had that answer.
Just wait.
I've read yours. You didn't say it either. Okay. I only have like 3 papers left to go, or 4 on page 1. I do have a couple that say steel and iron, and that's as close as I've got.
If I put metal, it's because I was just rushing.
Okay, no. Nobody has ferromagnetic.
Sorry.
Alright. I got hope for 4th period. Alright, so what are some examples of ferromagnetic? No. What are the 4 examples of ferromagnetic y'all are supposed to know? Nickel, cobalt, steel, and iron. Alright, and is that above magnet temporary or permanent?
Permanent.
It's permanent. Alright, it's a bar magnet. All those bar magnets back there are permanent magnets. Alright, some of them are a little less permanent because I've inherited those, and I don't know what on earth those people did to those poor magnets. They don't work. Okay, they don't work.
It's temporary.
Well, they were permanent, but they've been brutalized.
So
Now,
magnets are temporary.
no, they're permanent. We're going to make temporary magnets tomorrow. We might get started on it today, but I'll be surprised. All right. So Earth is a magnet.
Keep this in our notes. For review.
Okay.
Yes. I'll
you,
raise them.
you keep that as review.
All right, thank you.
Now, yesterday, I guess it was yesterday, I told you that we were going to put a nail in between a strong permanent magnet. The nail is ferromagnetic. The magnet is a strong permanent magnet. And hopefully the strong permanent magnet is vibrating our electrons into alignment so that the nail will behave as a magnet. Somewhere up here I had a paper clip, but I think I just used it to put those copies together in case Derek or Joseph ever comes back to their shared school contract.
We got one right here.
Well, their name's on that one. So if I put my paper clip there, and I take my nail, is my nail going to work as a magnet?
Slow, what do you know?
Kind of. It's not fabulous, but it will.
What was that talking about the magnet yesterday?
Mm-hmm.
I was snapping.
It's not fabulous,
It's straight now. They're going the same direction mostly.
but it is working to some extent to pick up the paper clip. Okay? So, you can take a strong permanent magnet and put a ferromagnetic material there to magnetize it.
What if
Alright.
I was in between 2 giant strong permanent magnets? It was like a day.
Yeah, but you're not ferromagnetic. You're not ferromagnetic.
Iron in my blood down 70%.
You're not ferromagnetic. All right, so what is magnetite or lodestone?
Touching me.
All right, these are magnetic. Let me change colors. All right, these are magnetic rocks. Okay, these are magnetic rocks. And I will pass one around. All right. Now, if I put this rock close to the magnets, you'll notice that the rock will stick to the magnet.
magnet.
Oh
Yeah,
my
okay, it's just a magnetic rock. All right, I'm pretty sure the one I have is magnetite. Unfortunately, I've lost the label over time. You will notice inside the bag, there are all these little slivers, and the bag is kind of dirty because, again, what's coming off of the rock. All right, little tiny pieces of magnet, or if we shaved them down even smaller, they would look like what from yesterday? Iron filings, not fillings, people, they're filings.
Don't get with the great.
Fillings have two L's. Alright, they're iron filings, okay? So, again, don't open it or get it on your hands or get it in your eyes, alright? Your hands will get really nasty and dirty like they did yesterday. But you can see the little pieces sticking off the end. And I'll pass it around so you can see the rock, alright? But it's just a magnetic rock, alright? So, if the Earth has magnetic rocks in it, that means some things about the Earth that's important for us in terms of magnets, okay? So, alright, I need you to draw this picture because we're going to explain some things about a compass that some of you may or may not know.
What's this?
I know he didn't just ask me that. Don't tell him if he doesn't know the answer.
Right?
What did he ask?
He said,
He asked what was in the bag.
Is this a meteorite?
We got like dirt on it.
It is dirt.
It's lotion.
Iron filings.
Yes, those are iron filings, not fillings.
They're fillings.
Well, y'all seen Avengers, right?
Two L's.
Bro, Iron Man suit probably not even made of iron.
Race.
You saw it, bro?
Did you know one where it's like
Shut up.
all over? It's not. It's nanotech.
It's not even iron.
I hate that. I know.
Well, you can go outside and find rocks like that. As well.
What?
You can go outside and find rocks like that.
Yep.
No, you can't.
Is there like a certain place to look?
Yep.
No.
No, you can't.
I have to research it. I don't know where you look.
Oh, thank you.
Ew. Yes.
Just that ew that someone called.
Chest out.
No,
We have Justin today, right?
No, we have like this.
Wait, really?
Yes.
Really? You can't keep track of where you're supposed to go?
Are we supposed to draw this?
Alright.
Wait, where did we go today?
Please don't taste.
It's A-Day. We go to Jessup.
Oh, thank God. I thought we were gonna go to Legends.
We was there yesterday.
He wasn't there.
Can't stand there, bro. Should be like,
You really can't remember which class you're supposed to go to.
I wasn't here.
We've gotten so far in the
You can't remember that the day before.
No. I knew that we were supposed to go to Jessup's today, but they confused me because I thought they said we were going to Legends.
Alright, does everybody have the Earth drawn and labeled?
No.
Hurry up.
No.
I'm sorry.
It's a hole in your bag.
I'm sorry. I can get a different bag.
I want to school to that straightforward.
Yes.
Did you just have this?
Can I leave one?
I will get louder.
Just say it. Just what I exactly what you said.
That is
Oh.
Here, do I need to get a new bag?
Yes.
Okay, say this.
Special
I'm gonna say this.
It's a rock.
Really? Is it a rock?
You did it.
It's a magnetite.
I did rub it. Don't turn on the
What about
gas.
rocks and like that?
Jose.
Royal, come here.
Sound like you in the channel.
Alright. So we should have had time to get it. Now make sure you throw in the labels because the explanation makes no sense about the labels.
Then I realized it was Magnetism. I got mad. I was like, that's bush. Yeah, I was like Magnetism. Yeah, but you know.
If you got any of those iron filings,
I just realized that.
I was just like, so what's that?
people do it so early, they put you in this shop.
I'm not gonna get into it. Actually,
You can't say it.
you know, grill. Too much. Grill.
All right. Everybody got it? Now, I need you to sit down, Trevor. Now, I need you to notice something about the Earth. All right, everybody knows this is the equator, right?
No.
What's the equator?
Yes, ma'am.
It gets hot around there.
Now,
That's what it is.
notice what I labeled about this. Now, this, all right, first of all, is essentially a giant bar magnet. Let me change colors on that. All right. Through the Earth runs a giant bar magnet. All right. Notice that it does not line up equally with the poles. All right. That there's a pretty big differential between the North Pole and where the bar magnet is. Okay. And where the South Pole is and where the bar magnet is. They are not equal. That they're spaced out a little bit there. Okay. Now, notice that there's space between the bar magnet and the North and South Pole. They're not lined up equally. Okay, they sit at an angle. Now, the other thing I want you to notice is the way that I labeled them. Okay? This is the geographic north.
Excuse me, you're in the way, sir.
And it's the magnetic south. Okay? Does everybody see that?
Yeah.
Now, when I say the geographic north, all right, I'm generally referring to, and I mean no jokes when I say this, what we all think of is the one with the polar bears and Santa Claus. Okay? Now, but it's the South Pole on the magnet. Okay? So this is where our south is on the magnet. Now, when you think of the magnetic north, it's where the geographic South Pole is. It's where Antarctica is and where the penguins are. Okay? This is our North Pole on the magnet. Okay? Now, so this bar magnet essentially runs through the Earth. Okay? It bisects the Earth. So, this causes several things to work this way. Yeah, Nigel. Yes. Now, is everybody caught up? They got the picture? Good. Okay. So, if a bar magnet hangs down from a string, same bar magnet you guys have been using, we tie a string around it and we hold it either with our hand or we tie it from something and we have it spinning. Okay? Which way will the magnet point? Okay? When it stops spinning, it will point a direction. Does anybody know which way it'll point? It'll point north. Okay? It will point to the north. Okay? So, why? Here, give me that before you punch the hole in the bag. Now you gotta go get another bag before it's here. It is a rock, but it's got sharp edges.
Why did it turn yellow?
All right, so why will the bar magnet point to the north? All bar magnets will point north. It doesn't matter which bar magnet we're using, it will point north. Why will the bar magnet point to the north? Okay. The North Pole on the magnet is attracted to the South Pole. Okay, now, where is the South Pole in the picture? I'm coming right back. Where is the South Pole? Remember, this is the bar magnet, right? So where is the South Pole to attract the North? It's at the top, which is what?
The North
It's
Pole.
the geographic North. But remember, that's not what's attracting the magnet.
Yeah.
What's attracting the magnet?
Just magnetic south.
The magnetic south. Okay, so that's what I'm going to be writing about in the answer. So the north pole of the bar magnet is going to be attracted to the magnetic south pole. Okay, so the north pole on the magnet is attracted to the south pole. And in parentheses, I'm going to write it's the magnetic. Here, I won't even put in parentheses. The magnetic south pole is located at the north pole.
It makes sense.
Does that make sense?
Yes, ma'am.
Okay. That's why it points that direction. All right, we caught up? Do I need to wait? Where are we at? All right, put your phone up. I didn't say hold it up. There's a difference.
I like that. That's smart. Go home. We're probably gonna use that eventually in the season.
All right, is everybody caught up with me? You're there, you really? I can't tell if you're getting ready to fall asleep in your chair or if you're caught up with me. Okay. All right, so same concept. Particularly my ROTC people. Y'all work with compasses, right?
No.
No? Y'all don't ever get into compasses? I don't think y'all would.
Boy, they be doing poetry in that class. What you talking about?
Poetry.
Yeah, they be reciting poems and stuff.
No, they don't.
Yes,
Y'all
they do.
recite
Don't
poems,
y'all?
do you?
Y'all do that. Y'all recite that one, right?
Y'all do poetry?
She lying, bro. I was in that class, bro. I remember. Yeah, y'all recite poems.
What poem do y'all do, Otanel?
Yeah, they do poems. I wasn't
9
playing.
poems?
I wasn't playing. They do poems.
memory though?
Well, give me a poem.
Long one or short one?
A short one.
Life.
All right, recite it.
Crust of bread and a corner to sleep in, and it's not an out even. A pint of joy to pick up trouble, never left, but also double that is life. A crust in a corner that love makes precious, with smile to warm and tear to refreshes. And joy seems clear and cares come after, and the mornings to find us voice for happiness.
That jump go hard.
Okay.
That jump hard. Oh, we took. When I was in there, we took a field trip to like pick up trash. Right? I found a bedpan with piss in it. I didn't pick it up. I was like, man.
Shocking,
I
Tyler.
was like, man, that could stay right there, boy. I'm not picking it up.
You had gloves on. All right, so what direction does a compass needle point? So since ROTC doesn't do this, let's just pretend they do. All right? If you go into the military, you will learn to read a compass.
I mean, I did it.
Okay, so what direction does the compass needle point?
Hold up, I got it on my phone.
Okay.
You got the little compass out in the little red thing.
Yeah, what direction does it point?
South.
Okay, because the compass needle always points one direction.
North.
It points to the north. Okay? So,
Yo, that's how it works, huh?
all right, so why does the compass needle always point north? It's a magnet. Okay? First of all, a compass is a magnet.
Sorry.
Stop coughing.
All right, a compass is a magnet.
I swear.
All right, so if a compass is a magnet and it always points north, why does it always point north?
It's a magnet, and that's where the south thing is.
Why does it always point north?
That's where the south pole is.
That's where the south pole is. All right, the north in the compass The needle's a magnet. All right, is attracted to the magnetic south pole. That is at the geographic North Pole.
That's a lot of poles.
That's pretty good, ain't it?
Mario, Tyler, hush.
I don't have glasses. That's all up here. I'm not-
What happened to your glasses?
They're at home.
They're just at home. Okay.
Huh?
I said, okay. I've had 2 students lose their glasses, so.
Oh yeah. No, I'm responsible. I just look at them
them
and I'm like, oh, they're dirty. I'm not gonna clean them today. You have to believe. Because I gotta go ride the bus, you know.
I see.
I gotta walk up this hill.
So when you get the moped, are you riding the moped to school or still riding the bus?
ma'am. What?
Okay, all right. I just thought I'd ask.
They're making fun of me though. It was like, man, that job. Making fun of me.
They're making fun of you till you pass them on, you pass them on the moped.
Yes.
Throw up your hand and wave.
Yes. That's just illegal, bro. Mopeds ain't even supposed to go 70 miles per hour. But don't tell nobody though.
Depends how
I
many
ain't gonna go
CCs
there.
they have.
Huh?
Depends how many CCs they have.
I think originally it was like 50, but then he put a turbo on it. So it was like, now it's like going 70. So I don't know. Enough to get on the highway, that's all I
All
know.
right, so we're going to talk about electromagnetism. This is what we're going to do tomorrow. Okay? So if you're not here tomorrow, you're missing the lab. We're going to build electromagnets. I went and got the batteries yesterday. So we're ready to go. All right, so what is electromagnetism? First of all, what are the 2 parts to that word? Okay, so give me what electro is short for. There we go. Okay, so this is the relationship between electricity and magnetism. All right, so if we have electricity and magnetism, we're going to create a current using a what?
The battery.
Which is why I had to go buy batteries last night. And we're going to create a magnet using this electricity.
That's cool.
Okay? Now, everybody gets 1 battery. I'm going to tell you in the directions tomorrow how not to fry your battery. Some of you will do like you always do and ignore me. And you will fry your battery in the first 5 minutes. And then you'll be like, whoa, my electromagnet won't pick up anything. And I'll be like, I know. And there's nothing I can do for you. I spent $30 on batteries last night. You get how many batteries? 1. Okay? If you do what I tell you not to do and you fry it, I'm sincerely sorry. No. Okay? I hope that you don't fry it so I can use them again. Now, we have 2 scientists in this unit we're going to talk about. The first one is named Hans Christian Ørsted. Trevor. All right, Hans Christian Ørsted discovered that all wires with a current flowing through them generate a what? Say it. You can just say a magnet. All right? Okay? Or you can say magnetism. Doesn't matter to me which one you use. All right? So I'm going to pick on Mario over here because he's got his phone plugged in. So he's got what running through this handy dandy little cord right here?
Electricity.
Electricity. So because electricity is running through this cord is making a magnet.
Yeah.
Now, is this cord going to be a strong magnet?
Yeah.
No. It's not going to be a strong magnet. Okay, it's going to be a pretty weak one. All right. However, There are things we can do to make that a stronger magnet. And that's what we're going to spend our last 20 minutes talking about. What can we do to make that a stronger magnet? Because that's what the lab is about tomorrow, is what things can you do to make it stronger and weaker? What can you play with to increase and decrease the strength of the electromagnet? Well, I'm only giving one battery. So am I going to give you the opportunity to really make it stronger with increasing your electricity? No, now it'd be fabulous if I had a way to let you use the outlets, but I'm not willing to shock anybody senseless.
Yeah, it's not gonna blow up. Wait, you can actually do that though?
I could give you the opportunity to do that, yes, but I'm not.
No, I mean but that's possible, right? So
yes.
Use electricity to make a stronger magnet.
Why on earth are you throwing paper in the air? All right. So your electromagnet tomorrow has to have 3 parts. All right. The first part is a solenoid. This is the part that will drive most of you insane. And some of you will come to me and go, Miss Wall, I need help with this. I will not help you. So don't come to me and say you need help. Yavian, you hear me? Before you come over and go, Miss Wall.
Wait
Okay.
That's why you're sick.
Yeah, stop
can't get
coughing,
better.
man.
Because you've been sick for like 3 weeks.
All right.
Shut up. I don't hear it.
A solenoid is a long coil of wires. Okay? So you have to coil the wire yourself. Did anybody take the electronics class, Mr. Butts?
Yeah.
Okay, then you probably made a solenoid. You remember taking some nails,
You
coiling
did?
the wire?
Yeah.
Okay, you made a solenoid. Okay? Remember doing that with the wire? Okay, you made one. All right, ours does not have to be anywhere near as nice as Mr. Butts. Okay? But if yours is real ratty, your electromagnet will not work as well. You need to make a neat solenoid. Okay? So, that's just something that will make it easier. So, several of you have asked what this thing is. This is a really old school timer. This little thing would, on tape, it would tick. And you can hook these up to an electrical source to make it work. It's not why I got this out. That's not an electric. That's not a record player. All right. The reason I got it out is these 2 red pieces here are solenoids. Okay. They show a beautiful piece of wire that's been coiled. Okay. So I'll pass it around so you can see how neatly the piece of wire has been coiled, so that you have an idea of how neatly you need to coil your wire tomorrow. Okay.
It looks like sewing. You know the sewing things that are wrapped around.
Okay. It just has to be neat when you coil the wire. Now, the second thing you need is iron. So tomorrow, to have iron, all right, I could be Trevor and say we could use Urelli, but that'd be tacky. All right, so we're going to use nails. Okay? Because we just need some steel. Okay? All right? Because I can't afford, you spell S-T-E-E-L or S-T-E-E-L.
That's how you spell it?
You can put an E on it or leave it off. Trying to break. Now, because the easiest way for me to provide steel for y'all is just to go to Lowe's, buy blocks of nails. That's what I do.
They're not American.
Okay?
Forever.
American.
You guys have the stupid British people spell it.
Miss Wall, what's the difference between the 2 spellings of color?
One's British.
I want to say one's British and one's American.
Color, what I say, exactly.
Sort of like aluminum and aluminium. In the United States, we say aluminum, and in England, they say aluminium.
Aluminium is cooler.
Yeah, you're just looking at how neatly the wires go.
Or not, say, like,
Why don't?
Come on, Grace.
Man, ain't no ice and soul.
All right, so tomorrow, you guys are going to use nails for your iron. Because again, it's a form of steel. And then you've got wire to make your solenoid. Now, some of you we'll just sort of take your nails and wind your wire like this.
That's terrible.
Exactly. And if you do it this way, your electromagnet won't work worth beans. Okay? Now, some of the lab will ask you to make 2 layers, 1 layer. It will ask you to make 10 coils, 20 coils. All right? Now, this looks like crap, right? So the reason I pointed out and sent the coils around for you was to illustrate that these need to be done neatly. So when you're doing this, you're going to need to make a couple loops and then push them down. Make a few loops and push them down. Okay? Feels a little bit like I'm knitting when I do this through some weird nails. Okay? So that they're neat and they resemble what's there. Now, you don't have to keep a short end here, but you need to make sure that the coils look nice. Okay? So that they're neat. You see what I'm doing? So they look nice. Now, some people struggle with this and getting them to look nice, which is why I made that crack about Diavion and not being willing to help. Because some people have a hard time getting them to stay on the nails. Okay? But it can be done. Some groups have an easier time than others. Okay? Everybody got it? But that's what you're going to be doing. Now, if you look at number 3, where's the current coming from? Look who's here. All right. Where's the current going to come from? The battery. All right. Again, we can use a battery or we could use a motor. But we're going to use the battery. All right. There. Here is your copy, dear. That I promised to give you when you signed it. All right. Now, everybody, did I go back too fast? All right. Have I waited long enough?
Yeah.
All right. So, number whatever here. Why is iron a good metal to use for an electromagnet? Why do we use iron and not copper or aluminum? It would have been easier for me to buy aluminum foil and to go find nails. Why didn't I use aluminum foil?
It's a better,
Guess what?
Ferromagnetic.
It's ferromagnetic. Or it can be magnetized. For those of you who are like, what's that word mean again? All right, it can be magnetized. All right, did my timer make it around? So I've got my solenoid back. Where's that?
One person
Can you pass it on and stop playing with it?
Oh no, I wasn't hearing that. I was like, what is that noise?
Nigel.
I thought it was the last one.
The whole side of the room hasn't seen it.
They pass it this way and then.
Yeah.
Stop attacking me. I'm sensitive.
Ow.
You know that Muslim kid who put a clock and then like they call the police to the top.
All right. Does everybody have what they need?
Like a
All right.
You got advice?
Oh, excuse me. I didn't hear you, really. Thank you for pointing that out.
Oh, there's a white kid built a nuclear reactor under his basement. He got praised for it, but he put a clock.
All right. So what things can we do to make our electromagnet stronger? All right. They all come from these 3 things. Okay? All 3 answers come from these 3 things. All right? So what can we do to make it stronger? That's sort of some dead silence out there. They come from these 3 things in your notes. What can we do to those 3 things to make our electromagnet stronger, Mom? Do what?
Bigger nails, bigger battery.
All right. right, the bigger battery I like. All right, so we can add more current. All right, so that could certainly be a bigger battery. Or in our case, 2 batteries. Because I don't have any bigger batteries, so we'd have to use more batteries. Okay, so add more current would certainly work. All right, so now we're down to the nails and the solenoid. All right, so what can we do to either the nails or the solenoid? Huh?
What?
I said, what can we do to the nails or the solenoid? What is a solenoid? All right, so what would we do to the coils?
Short.
Probably. If we do that.
Hey, do not put that in that outlet. No, you cannot. It will short circuit the outlet.
You don't want to kill me though, right?
I have no idea, but I'm fairly certain the answer is no. It will probably shock the snot out of you, though.
Put it in.
I did.
Bruh.
I'm not sure there's enough plastic on that wire not to shock the snot out of you. That's 120 volts in that outlet.
Do it. Do it. Do
A
it.
battery is like 1.5.
I was like,
I'll do it when I'm done.
look, yesterday is funny.
How about you know?
You would have been dead, bro.
Hey, you.
You would have been dead.
So, what can we do to the coils?
We can make them tighter.
Not make them tighter.
Shorter.
Not make them shorter.
Longer.
Longer.
Nope.
Make them wider.
Add
Thinner. Add electricity. I don't know.
add something to them.
Add more wire.
Add not more wire.
Less wire.
Nope, you're on the right track.
Add what? Add
Throw it away.
more.
Add more coils.
I was gonna say that, but
Okay, you're gonna have more coils. So if you have 10 coils, you could add, instead of 10 coils, you could have,
30.
let's say 30 coils. Okay, 30 coils would be stronger than the 10 coils. Okay, so more coils equals stronger.
This is
All right, the last one is the nails.
It's a record player.
It's not a record player. We've already been through that.
But
So
doesn't
what
it
can
look
we do with the nails?
Add more.
Yes. Add more
Nail.
iron.
Oh.
Okay? Remember, the nails are just our version of the iron. So add more iron. Okay? So anytime we have more iron, then it's going to be more or stronger electromagnet. Okay? So tomorrow you will take the nails out. So when we go back to Mario's phone being plugged in, does he have any nails or iron in that wire? No. So is that a very strong electromagnet? No. Does he have any coils there? No. That's not a very strong magnet. He's just got it plugged in. Now, is an electromagnet temporary or permanent? It's temporary because it's only a magnet when,
Electricity runs through it.
that's right, when connected to the battery.
Bro, he would have stopped.
All right, it's only an electromagnet when connected to the battery. If it's not connected to the battery, it's not an electromagnet. So, tomorrow when you're doing this, are you going to leave it connected to the battery? No, it'll
Oh.
drain your battery.
You better take it out.
Okay? You'll connect it for very short periods of time. Also, it's going to get very, very hot. What? No.
Back up, back up.
It's not time to back up. We got one more thing to do and then we're
Back
done.
out.
Alright, it'll get very, very hot on the wires and the ends of the battery the longer you keep them connected. Some of you may yell, Miss Wall, I just got burned. Don't keep it connected to the battery. Alright, so the last thing we have to do
Oh, that's a beautiful.
is where is the electromagnet the strongest? Alright, let's say that this is our battery. Okay, we got some positive and negatives there. And I'll just write BAT for battery. Alright, we got some ugly nails. This wall can't draw. Thanks.
I think
All right. So there's my nails that look like teeth.
Ew.
Well, I'm just saying, they look like really ugly teeth. All right, so I got some wire. I coil it around my batteries. All right.
You just like make the positive at the top and negative at the bottom. Normal battery.
That's a good.
Sorry.
All right. So where is my electromagnet going to be the strongest? So when y'all are trying to pick up stuff tomorrow and you're looking at this and you're like, Ms. Wall, where do I pick it up at? Where is it the strongest?
Can I
Where are
guess?
you going to try to pick up stuff?
Can I guess?
Sure. No, not the battery. All right. This right here is called the poles. This right here is a pole. All right, those two things are called the poles. Now, this is the part I hate teaching because you've just learned that bar magnets are the strongest where? Where are bar magnets the strongest? The poles. Now, an electromagnet is strongest at the poles and, what did you say, Trevor? And the middle. So you can also try right there. Okay, I find that with our batteries, they're the strongest at the poles. Sometimes the middle's not bad, but I haven't had the greatest of luck with the middle. Give it a shot. See what happens. Okay? Yeah, I'm done. Okay? But
Back up.
but tomorrow we will build
I'm backing up.
and we will see what we can do.
Yes.
Hopefully, you guys will listen when I give you some basic instructions that remind you, and you will not kill your battery in the first 5 minutes. If you do, I'm so sorry. You only get one.
You get 0.
Well, you won't get a 0 if you answer the questions, but your lab's going to suck. Yeah, I'm moving. I'm just turning off.